Geometrical representations. The number s equal to a plus bi can be shown either as a translation of the plane, a units in the x direction and b in the y direction, or as the point s with coordinates a comma b. And the diagram shown previously is called as the Argand diagram. Show in an Argand diagram the roots of z power 4 plus 4 equal to 0. We know that the roots of the equation z power 4 plus 4 equal to 0 are 1 plus I, 1 minus I, minus 1 plus I, and minus 1 minus I. Each of these points can be represented in an Argand diagram as shown in the figure. Taking real numbers on the x-axis and imaginary numbers on the y-axis. Show in an Argand diagram the roots of z power 5 minus 6, z power 3 minus 2, z square plus 17z minus 10 equal to 0. We know that this polynomial has 5 roots, 1 which is repeated twice and 2 is the second root, and the conjugate complex pair minus 2 plus or minus I. These 5 roots can be represented as shown in the figure. We can see on x-axis the root 1 and 2, and in the left side to the y-axis we can see the 2 roots, totally 5 roots. Complex numbers are represented just like vectors in 2 dimensions. S equal to a plus bi is one complex number, the other complex number is t equal to c plus di. The sum of these two complex number is represented by the vector s plus t equal to a plus c plus b plus d I. And subtraction of the complex numbers can also be represented using vectors as shown in the figure. Vectors s and t, their difference is represented by vector z equal to t minus s. The modulus in the figure shown, the distance covered by the translation s equal to a plus bi is square root of a square plus b square. In an Argand diagram, this is the distance of the point s from O. This is called the modulus of s, and it is denoted by modulus of s. If s is a complex number, modulus of s square is equal to s times s star. If s equal to a plus bi and t equal to c plus di, then distance st is equal to modulus of t minus s, which is equal to square root of t minus s times t minus s star. It can be written as square root of c minus a whole square plus b minus d, d minus b whole square. In an Argand diagram, points s and t represent 4 and 2i respectively. Identify the points P such that PS is less than PT. So in the Argand diagram, S is the point at 4 on the real plane, and on the imaginary plane T is 2i. So we need to identify the points P such that PS is less than PT. Let P represent a complex number z equal to x plus yi. The lengths PS and PT are given by PS equal to modulus of z minus 4 and PT by z minus 2i. Then according to the condition given PS less than PT, we can write modulus of z minus 4 less than z minus 2i. Squaring on both sides and writing the conjugate pairs and simplifying, we get 4 times z plus z star plus 2i times z minus z star is greater than 12. We know that z plus z star is equal to 2x and z minus z star is equal to 2yi. Substituting those values, we get PS less than PT implies 8x plus 2i times 2yi greater than 12. Simplifying, we get 2x minus y greater than 3. The line 2x minus y equal to 3 is the perpendicular bisector of ST, which cuts the axis at 3 over 2 comma 0 and 0 comma minus 3 as complex numbers. These are the points 3 over 2 and minus 3i. In an organ diagram, the point S represents 3. Show that the points P such that OP equal to 2SP lie on a circle. If P represents Z, OP equal to 2SP according to the given condition. Now modulus of Z equal to 2 times modulus of Z minus 3, squaring on both sides, replacing modulus of Z square with Z star and replacing modulus of Z minus 3 square with Z minus 3 times Z star minus 3 star, and simplifying, we get the equation z star minus 4z star plus 12 equals 0. Notice that modulus of z minus 4 square is equal to z star minus 4z star plus 16. So according to the given condition, OP equal to 2SP by implies z star minus 4z star plus 16 equal to 4. That is, we added 4 on both sides. So that by implies modulus of z minus 4 whole square equal to 4. Now taking square root on both sides, we get modulus of z minus 4 equal to 2. The interpretation of this last equation is that the distance of P from 4 is equal to 2. That is, P lies on a circle with center 4 and radius 2. Modulus of st equal to modulus of s modulus of t, and modulus of s over t is modulus of s over modulus of t. Modulus of s plus t is less than or equal to modulus of s plus modulus of t, and modulus of s minus t is greater than or equal to modulus of s minus modulus of t. S and T are the points representing minus 4 and 4 in an organ diagram. A point P moves so that SP plus TP is equal to 10. Prove that 3 less than or equal to OP less than or equal to 5. If P represents Z, then SP plus TP equal to modulus of Z plus 4 plus modulus of Z minus 4, so that Z satisfies modulus of Z plus 4 plus modulus of Z minus 4 equal to 10. OP equal to mod Z, which is equal to half of Z plus 4 plus Z minus 4, that is less than or equal to half of modulus of Z plus 4 plus modulus of Z minus 4, which is equal to 5. Also, we know that modulus of Z plus 4 plus modulus of Z minus 4 whole square equal to 100, and modulus of Z plus 4 minus modulus of Z minus 4 whole square is a positive number. So adding these two, we get a value which is greater than 100. Now if you simplify it, we get modulus of Z square is greater than or equal to 9, that is OP is greater than or equal to 3.